Greetings, fabulous math students. It's Mrs. Marcellus and Pythagoras. He just can't get enough of this chapter on ratios and rates and wants to learn more. Today we're going to look at ways to determine whether or not two ratios are equivalent and form something called a proportion. In our lesson, students will compare two ratios and determine if they are equivalent by finding unit rates and applying their knowledge of equivalent fractions. To determine if two ratios are equivalent or have the same value, you can compare their unit rates or you can apply your knowledge of equivalent fractions. Depending on the problem, usually one way will be much easier to use than the other. Shall we get started, Pythagoras? Okay, let's begin. In our first problem, we want to determine whether it is equivalent to buy 3 shirts for $21 and 5 t-shirts for $35. One way we can do this is to look at the unit rate. First, I'll set up the ratios. I would have 21 over 3 and 35 over 5. To find a unit rate, our denominator must equal 1. So in the first ratio, that would mean we would divide both the top and the bottom by 3. This will give us $7 for 1 shirt. In the second ratio, we would divide both the numerator and the denominator by 5 to give us that denominator of 1, and this would also give us $7 for 1 shirt. So yes, the two ratios are equivalent. Two equivalent ratios form something that we call a proportion. In the next example, we want to know if 20 miles in 5 hours and 45 miles in 9 hours are equivalent. Again, we'll set up the two ratios. We'll put 20 over 5 for the first one and 45 over 9 for the second one. It's really important when you set up your two ratios that you put the same units on top and the same units on the bottom. For example, we have miles and miles as the numerator and hours as the denominator. There's no way to easily get from 5 to 9 or from 20 to 45 by multiplying or dividing, so we would want to use the unit rates. In this case, 20 divided by 5 will give us 4 miles in 1 hour. I divide both the numerator and the denominator by 5 in order to get my unit rate with a denominator of 1. In the second ratio, we will divide by 9, and we learn that this is 5 miles in 1 hour. So our answer is no, they are not equivalent. 4 miles an hour does not equal 5 miles an hour. In this problem, we're trying to determine if 6 DVDs for $90 and 3 DVDs for $45 are equivalent. There are multiple ways to approach this problem. First, we will write our ratios. 6 DVDs for $90 and 3 DVDs for $45. We can use our knowledge of equivalent fractions to try to solve this problem. We can see that if we divide 6 by 2, it equals 3. We can also divide 90 by 2, and it equals 45. Since you can divide both the numerator and the denominator by the same number and get an equivalent fraction, these two are equal. You could also use the unit rate here and divide 6 DVDs by $90 and learn that you can get 6/100ths repeating of a DVD for $1. And if you divide 3 by 45, you will also get 6/100ths repeating of a DVD for $1. But that's pretty awkward. We usually wouldn't say how much we get for $1, so you can flip the ratios. You could say $90 for 6 DVDs and $45 for 3 DVDs. Now when you find the unit rate, you would do 90 divided by 6 and learn that that is $15 for 1 DVD. Then when you divide 45 by 3, you also find that it is $15 for 1 DVD. And those two are equal. You also can still divide the numerator by 2 and the denominator by 2 to get an equivalent fraction. So any way you look at it, these are equivalent and do form a proportion. Here we are shooting some free throws. If we make 3 free throws in 7 attempts and 9 free throws in 14 attempts, are these equivalent? To solve this problem, it would be easiest to apply our knowledge of equivalent fractions. We can get from 3 to 9 by multiplying times 3, but we can't get from 7 to 14 by also multiplying by 3. To get from 7 to 14, we multiply by 2. Since we can't multiply both the numerator and the denominator by the same number to get the second ratio, we know that these are not equivalent. You also could have divided and found the unit rate for each of these. You would have come up with a rather long decimal, but you also would have found that they are not equivalent. The Ubercool Math Club raised $168 by washing 42 cars. The Science Club raised $152 by washing 38 cars. Are their fundraising rates equivalent? In other words, did they charge the same amount per car? First thing we need to do is set up our ratios. The Math Club raised $168 by washing 42 cars. The Science Club raised $152 by washing 38 cars. We can't easily get from 168 to 152 or from 42 to 38. Probably the easiest way to solve this one is to find the unit rate. We would divide by 42, and when we divide 168 by 42, we learn that the Math Club charged $4 per car. If we divide by 38 for the Science Club, we also learn that the Science Club charged $4 per car. So yes, their fundraising rates are equivalent. Well, Pythagoras, that was pretty easy, wasn't it? Do you think we should join the Math Club? I think that'd be a lot of fun. This concludes our lesson on equivalent ratios.